to get infinite control over the airways, airline companies have been battling since day one. The Boeing 747, 8 and Airbus A380 are like giants in the sky. These big planes shuttle crowds of people across the globe faster than were once cherished. They bring airlines a mix of meticulous technology, luxury, and the hope of being the stars of their fleets. These advanced planes trace their roots back to the early days of commercial flying, when just moving a few passengers was a big deal. Before the Boeing 747 and Airbus A380 were not the only ones to dominate the aerials. There were numerous other colossal aircraft that had their moments in aviation history. Even though these big planes are impressive, aviation is always changing, and new planes are always trying to be better than the ones before them. The Boeing 747, affectionately known as the Jumbo Jet, held a revered status among commercial aircraft, symbolizing a new era of air travel. It was not only a marvel of engineering, but also a lucrative investment for those who backed it. However, its sheer size came with an astronomical price tag that stretched the limits of Boeing's financial capabilities. Boeing needed a lot of money to expand its business, so they tried to team up with big companies like General Motors, but General Motors turned their back from teaming up. They continued making cars instead of planes because car making was their forte, not a whole different industry like aeroplanes. After that, two other aircraft manufacturers, Northrop and LTV, teamed up with Boeing to share the cost and get the benefits of significant profits. The 747's origins can be traced back to a design competition for a large military transport aircraft, the C-5. It was a specially made aircraft for the US Air Force. Although Lockheed won the contract, Boeing had already realized that such a large aircraft would be more effective with a raised flight deck. This design allowed for a greater payload area on the main floor. So, Boeing started working on the two-level concept and implemented it in their next project, the 747.
Boeing used a lot of the design for the C-5 and put it into what became the 747, particularly in the wing and engine technologies. Probably without the C-5, the 747 would not have happened. Certainly it wouldn't have happened as quickly as it did.
Both the 747 and C-5 needed a new type of engine to lift their huge bodies into the air. According to the pilot Vintage Wings of Canada, Dave Hadfield,
to get a big jet like the 747 flying, you need powerful engines, and the 747 had 4 of them. In the 1960s, technology had advanced enough to create these high-power, high-bypass ratio engines. Basically, not all the air goes through the engine's core. The core is where the compressor, combustion chamber, and turbine are. Instead, a large shaft at the front of the engine turns a big fan to blow air around the core. These engines are quieter and more fuel efficient. This was all part of Boeing's big gamble with the 747, a huge plane with new, powerful engines, all being developed and tested at the same time.
Originally, the airplane was planned to have 2 long floors, like the A380, but Boeing didn't think the 747 would be a popular passenger plane for long. They thought faster supersonic jets would take over. Boeing was worried about safety. How would passengers on level 2 get out in an emergency? As a result of these complications, the second level was abbreviated, giving rise to the iconic hump of the 747. The cockpit was built behind the nose on the upper floor, so the nose could roll up extra space for the cargo placement. Then it became a dilemma of what to do with the area behind the cockpit. At first, they thought about putting the crew's rest area behind the cockpit, but then they changed it to a lounge for special passengers. Boeing added more windows to make it nice for paying passengers, because they didn't want to waste extra space out there, and made every effort to make that cavernous space usable. These changes show how the company adjusted its plans to make the 747 work well to return on investment from the paying passengers. Now, the early 747 utilized their second floor just right behind the cockpit by using it as a bar and entertainment area for the first-class passengers. This was to ensure they could enjoy their flight time in joy, not in stress. These areas, however, were not accessible to the occupants in the event of takeoff or landing or any critical situation. This was imposed to avoid any riskable situation like passengers bumping with each other during turbulence or any slip-off leading to injury. Rather, passengers were expected to remain in their first-class seat while seatbelts fastened. But that safety issue was taken into consideration, and alternative options were considered too. This deck was modified with sufficient safety with the inclusion of some second deck escape chutes, so the passengers can immediately evacuate the deck at the event of occurrence. This led to that aircraft company to replace the bar with the second deck escape chutes in their future-built aircrafts, with seats being loaded up, all to increase their passengers' capacity and generate more income from there.
I was a child then when the 747 first came into commercial service in 1970, and what I remember was the passenger appeal. They had really studied things from the passenger point of view to make it a more pleasant experience to fly somewhere.
With all the seats on the upper deck, the term double-decker seemed more than just apartment advertising agencies bought into something unique this time to attract people. Some airlines even painted extra fake windows on their 747s to make them look more impressive in spite of no upper deck in them. But the idea of having two levels on an airplane wasn't new. Before World War II, Short brothers had already made a flying boat with two decks called the Short Empire.
The Empire flying boats were built to serve the Empire, obviously, and did quite a job between the wars and the 30s flying the kangaroo route from London to Australia. And of course, they had the most magnificent stops along the way, carrying 25 passengers and 2 or 3 stewardesses through places like Baghdad and Kolkata.
The deep hull of the boat gave enough room inside for a second floor. The top level had 3 main parts: the cockpit, an office, and a room for sorting mail. Interestingly, these flying boats derived its manufacturing design from a bomber plane. Passengers stayed in a fancy lower level with a smoking room, a kitchen to make food for travellers, bathrooms, and 3 cabin areas. At the very rare of the Empire flying boats, they had the mail area. The comfortability with flying on these planes makes the passengers pay through the nose. Passengers had to pay as much as they earned in a whole year for a trip across the Empire. Surprisingly, for the British, the most important cargo wasn't the passengers themselves, it was the mail. Short Brothers double-decker flying boats revolutionized communication within the Commonwealth. With this new mode of transport, people across the world were brought closer together in ways never seen before. Business people, government officials, and families living abroad all benefited from this newfound connectivity. The world began to seem much smaller. Boeing's double-decker Model 314 was the successor of the Empire flying boats, and they were even bigger. When these planes were in service with Pan American World Airways, they were called Clippers.
It had sponsors instead of whip floats, which was thought to be original and thought to look much better. And it went into service for Pan American Airways from San Francisco to Hawaii and out into the Pacific Islands to Australia, eventually.
When set up properly, they could carry up to 77 passengers, more than 4 times the capacity of their British counterparts. These planes also had a large catering staff, including chefs from prestigious 4-star hotels. The 314 was an impressive engineering achievement, building on Boeing's earlier work with the massive XB-15 experimental long-range bomber. It inherited not only the bomber's wings, but also valuable lessons in building very large airplanes. Lessons that are still relevant today. 75 years later, both of these early double-decker flying boats were heavily involved in the events of the Second World War that followed. The considerable size of Pan Am's various Clippers also meant they had much greater range, enough to cross the Atlantic Ocean. The prospect of flying across the Atlantic during peacetime was a sheer achievement, but it would doom to failure in the harsh realities of war. If England seized the same fate like other European nations, the United States would need to combat Germany from afar. Therefore, bombers that could make round trips across the Atlantic, aircraft with even greater range than the enormous XB-15, would be very much needed. In 1939, Getting a plane like that large was nearly beyond dreams. Yet, the exigencies of war turned this necessity into reality. By 1946, after the war's end, the first B-36 bomber was introduced in Fort Worth. This massive aircraft could carry sufficient fuel to fly nearly halfway across the globe. Despite its already substantial size, it was later converted into an even larger double-decker transport, the XC-99. While it shared many structural elements with the B-36, including the wings and tail, the most distinctive feature of this aircraft was its unusually tall fuselage. It almost appeared as though two fuselages were stacked atop each other, giving it a somewhat peculiar look. Although it might not have won any beauty contests, the aircraft boasted a substantial capacity, able to accommodate 400 troops at once. The decision to develop a military transport version was likely influenced by the shared components with the B-36, simplifying production. There was also anticipation that a civilian model might attract interest from major airlines. Indeed, Convair had envisioned a passenger plane known as the Model 37, which attracted genuine interest from several US airlines. They were considering a double-decker design that could offer luxurious accommodations for more than 200 passengers, presenting a unique and exciting challenge for designers. However, the double-decker aircraft, regardless of their appealing 400 seats capacity, merely succeeded in acquiring any commercial orders for the passengers' flights. Airlines like Pan Am and American seemed to lose sleep over its huge fuel and operating costs due to its giant size. Even if military could afford it, commercial operators will slump simply to fund it for the intended use. Those 400 seats could be of no use to make the XC-99 flights economically viable if they failed to attract sufficient passengers. Additionally, there were practical concerns about airport capacity. Although the war had prompted the construction of numerous airfields, most airports were still relatively new and not equipped to handle large surges of passengers efficiently. Although the XC-99 was used as a troop transport, it didn't significantly boost Convair's financial standing since it was a one-of-a-kind aircraft. Over time, more practical options, like Douglas's C-124 Globemaster II, became available. Nonetheless, the XC-99 continued to serve in the Air Force. Despite its unique design, the aircraft still offered valuable support during its service. The XC-99 wasn't the only pioneering double-decker aircraft of its era. Even before the B-36 was converted into the XC-99 for the Air Force, the US Navy had already begun exploring the concept of a massive passenger plane in 1942. Coinciding with the US entry into World War II. During this time, the Navy collaborated with Pan Am on a visionary project called the Constitution. Even amidst the war, Pan Am was forward-thinking, planning for the post-war era. This unique collaboration between the military and a civilian airline marked one of the grandest experiments in the history of air travel. This partnership was particularly special because it melded the military's financial backing and support with Pan Am's expertise in passenger needs. Their joint goal was to create an aircraft that could serve both military purposes and commercial passenger needs effectively. Although the military paid the bill, there were significant challenges due to the aircraft's size and weight. The solution to the design issues of the Constitution came from a competition between two rival aircraft companies. Just a few years earlier, Curtiss Aircraft had been working on an advanced 2 or 4 engine airliner, the CW-20, which was to be much more advanced than the Douglas DC-3. Their goal was to create a pressurized cabin that could fly at higher altitudes than previously possible. Boeing was already exploring new territory with their Stratoliner, a pressurized airliner built using parts from the Boeing B-7 bomber. Inspired by this, a Curtiss designer thought he could do even better. His team developed a new design where the cabin was cylindrical, allowing for better pressurization and space use than the Stratoliner. They created a more efficient shape by creasing the fuselage and adding a floor along that line. This design, which they incorporated into their CW-20 model, featured a double bubble structure with the top level for passengers and the bottom for cargo. This innovative layout was both space efficient and strong.
The double-bubble fuselage was used because of its more efficient structurally. Its lighter structure provides extra room in the belly for cargo and a nice wide cabin for the passengers, and became very popular. Still used today in numerous transport aircraft designs.
The C-46 became a widely produced military transport with 2 engines and no pressurization. It was larger than the C-47 Dakota, but maybe not as immensely embraced as the C-47 Dakota. Chief designer L. Willis Hawkins recognized the double bubble's potential for the massive Constitution project.
Which is the biggest airplane we ever owned. You know, these were airplanes that had spiral staircases for half a double deck. This is a huge airplane.
The idea of integrating 2 levels inside the airplane ensured pressurization for both floors. As soon as the design came into effect, the team got the green signal to start planning and building the airplane, but the task is not as cakewalk as any other ordinary aircraft building. To execute this, they were required to make a massive hangar with 4 acres, big and 6 stories height. This measurement was gauged to fit the 150-foot-long double-decker fuselage and 190-foot wings. Because of the priorities of the war and the challenging size of the Constitution, the first one of its kind didn't fly until November 9, 1946. It soon became apparent that the plane lacked sufficient power, especially during taking off with a full load. One solution they tried was using rockets to help with takeoff, at least until they could get stronger engines. But the first time they tried it, it almost faced a consequence.
So I got out there and started down the runway. Lift the nose off, just before liftoff. I said fire the rockets, and I pulled back on the yawl. Got airborne, and nothing happened. Not a job bottle fire. Now we're on what we call the backside of the power curve. Your drag bag is higher than your acceleration, and you're in iron. You're just going long. And something we hadn't figured on the drill hall at PA River was dead ahead of us. And we were below the L, the top. There's no place you can go. So sitting there waiting on the crash to come, the top of the drill hall is a hemisphere. There's a thing called ground effect. When you get one wing, a half a wing spread from the ground, or a solid object, you get extra lift. Cushion of air came up that drill hole, and the formation was just right. It lifted us over the thing down. The far side got up, down on the right side of the power curve, and accelerated. It took us over 25 miles. We actually got over the river, which is about 25 miles west. We got over there, and the sun was on the water, and we finally were able to get control of the airplane again. But that was a long 3 minutes.
Airlines initially liked carrying many passengers per trip. Planes like the Constitution and Con's XC-99 didn't catch on. After the war, airlines like Pan Am showed little interest in extra-large passenger planes. These planes may have been too advanced for their time and lacked the power needed for their size. More powerful jet engines soon made these huge planes more viable. As both of these impressive experimental planes faded away, the Constitution at least left behind one major contribution: the double-bubble design. After World War II, Boeing took on a new challenge with the Stratocruiser, a double-decker airliner that was pretty efficient for its time. They built it much like they did the earlier Stratoliner, using parts from another plane, the C-97 Stratofreighter, which itself came from the B-29 Superfortress bomber. This new plane, flown by airlines like Pan Am and BOAC, had the B-29's wings, but featured a brand new double-decker design for passengers. Boeing's president, Bill Allen, really wanted to make the most of the technology developed during the war. He decided to start production without any confirmed buyers, which was quite a gamble. Luckily, it paid off big time. Pan Am's first order of 20 Stratocruisers from Boeing was a record breaker, the largest in commercial aircraft history at the time, worth over $300 million in today's money. Pan Am's president, Juan Trippe, was already a big fan of Boeing because of his positive experiences with the Clipper aircraft. He also knew about the Stratofreighter's ability to fly from New York to Seattle in just over 6 hours. which gave him a good sense of what the Stratocruiser could do for his airline. The double-decker Stratocruiser had a decent seating capacity for its time. The main passenger area on the upper deck could accommodate up to 100 people, while a lounge on the lower deck could seat 14 passengers. The Stratocruiser really set the bar for comfort back in the day. It had a pressurized cabin, something we hardly think twice about now, and even came with air conditioning. Over the first 6 years, these planes carried over 3 million passengers and crisscrossed the Atlantic nearly 28,000 times. But it wasn't all smooth flying. These planes were pricey to both buy and run, and unfortunately, they were also involved in a few serious accidents. One particularly tragic moment was on April 22nd, 1952, when Pan Am Flight 202 crashed into the Brazilian jungle. The disaster was caused by a propeller and engine breaking off mid-flight, resulting in the loss of all 50 people on board. It was a heartbreaking incident in the history of aviation. Despite its groundbreaking double-decker design, the Stratocruiser didn't see mass production. Only 56 were made, including the prototype. Boeing's innovative double-bubble fuselage, first introduced with the Stratocruiser, didn't just fade away though. It influenced other designs, like the Saunders-Roe SR-45 Princess, which was the largest all-metal flying boat ever built. At the end of the war, BOAC, Britain's flagship airline, was looking to reinvent transatlantic travel with a long-range flying boat. Saunders-Roe secured a contract to build 3 planes for this purpose. However, the project was ambitious and fraught with challenges from the get-go. Before the war, flying boats like the Empire and Clipper had been quite successful, but the landscape had changed dramatically. The war had not only left Europe in ruins, but also led to the construction of numerous runways and airports, rendering the once vital flying boats less relevant. Despite its regal name, the Princess was less about elegance and more about sheer size. Measuring 150 feet long with a wingspan of 200 feet, she was even larger than a Boeing 747. It took an impressive setup of 6 propellers driven by 10 engines just to lift her off the water. The extra engines were specifically to power the 4 inner pairs of propellers. Capacity-wise, she could accommodate as many passengers as the Stratocruiser, making her a giant in the skies. The first plane made 437 test flights from 1952 to 1954, but it was the only one that ever flew.
The unreliability of water operations and the penalty of the extra weight added to the fuselage to withstand the forces of landing on water made it totally uneconomic. The Princess died a quiet death, unfortunately, but it was totally unsatisfactory from an economic standpoint.
As jet-powered airplanes took off in popularity, the big seaplanes became less necessary. These new, faster jets didn't need water to land and didn't rust like seaplanes, which helped them quickly replace the old, slow giants of the sea. Unfortunately, this shift led to the downfall of the 3 SE planes. By the 1960s, there was a plan to use them to transport NASA rocket parts, but they had rusted so badly they had to be scrapped. It was a disappointing end for such impressive planes. In the 1950s, there was a smaller double-decker airplane flying around. It wasn't tiny, but its distinctive shape earned it the nickname Jelly Bean, also called the Dupont or Brigade 761 or 3 or 5. This plane was designed during World War II. It had 2 floors connected by an elevator in some models and could carry up to 135 passengers. The Dupont wasn't pressurized and was meant for medium-range flights. It first flew in February 1949. The French government bought 6 for Air France and 6 for the Ministry of Transport. Air France mostly used them for European flights from Paris to the Mediterranean. Only 20 were ever made, and like the Princess, they were phased out by jets. By the mid-1950s, jet technology had advanced, and planes like the Sud Aviation Caravelle came onto the scene, offering a smoother ride and longer range. The French Air Force saw an opportunity and bought up Air France's older planes, which they affectionately called Jelly Beans. They repurposed these jets as freighters to transport personnel and materials to nuclear test sites in the Pacific. The concept of a double-decker airplane was shelved for a bit, but the double bubble design still popped up in airplane designs occasionally. Over in Britain, the manufacturer Vickers Armstrong launched the Viscount, a successful short to medium-range turboprop airliner. Building on the Viscount's success, they introduced the Vanguard. Instead of adding a second passenger deck like Boeing's Stratocruiser, they used the double bubble design to create extra cargo space below and a more spacious cabin above. This design made the plane heavier, requiring more powerful engines, which Rolls-Royce supplied. Equipped with Rolls-Royce tin engines, the Vanguard became one of the fastest turboprops ever built.
It was known in Air Canada as the Mudderguard, by the way, and was highly regarded by the pilots. But its level of vibration in the cabin was a serious detriment to comfort. The tin engine was a troublesome engine at the best of times.
In the 1960s, Rolls-Royce tin engines were considered for a larger British double-decker aircraft. The Royal Air Force needed a new freighter capable of carrying helicopters or up to 200 troops. Short Brothers responded with the hefty Belfast design, boasting a cavernous interior. Its fuselage, with an 18-foot diameter, could fit 2 buses side by side and had a maximum takeoff weight of 100 tons, surpassing that of a Lockheed C-130 Hercules. Unlike earlier giants, the Belfast had a large circular section pressurized fuselage, not a double bubble shape. The RAF ordered 10 of these planes, which could accommodate helicopters and up to 150 troops, falling short of the intended troop capacity. Short Brothers also attempted to adapt it into a passenger plane, proposing a double-decker with close to 300 seats to BOAC, but the proposal didn't gain traction. In the 1960s, Vickers, a British company, tried to make a mark with their VC-10 aircraft, but faced tough competition from more popular jets like the 707. They came up with an idea to make the VC-10 stand out by doubling up cabin layers. This meant they would stack 2 halves of the plane on top of each other, creating a double-decker effect that could fit almost 300 passengers. Unfortunately for Vickers, Boeing announced its own double-decker, the 747, the same year their proposal went out. The 747 marked a new era of travel, making air travel accessible to more people beyond just the wealthy and famous.
In the 60s, if you went on a flight somewhere of any length or tall, it was either you were well off or there was some sort of business reason to do so. And people dressed up in, shirts and ties and all that sort of thing. Girls had little dresses on. But by the end of the 70s, the prices had come down since there were so many seats available, and flying was becoming part of every man's choice in life.
The success of Boeing's jumbo jets depended on more than just airlines buying the planes and passengers filling the seats. It was also crucial that airports had the infrastructure needed to handle these larger aircraft. The Boeing 747 might have faced some tough competition if Douglas, one of Boeing's main rivals, had followed through on a bold idea. Douglas, which later became part of McDonnell Aircraft, once planned a massive plane for American Airlines that could hold up to 550 passengers across 2 decks. But they decided against this grand design and went with a safer bet, the DC-8 Super 60, leaving the field more open for the 747. Despite being the largest commercial passenger aircraft for decades, the 747 faced challenges. While it was cost-effective when fully filled, operating at 70% capacity burned almost as much fuel, leading to financial losses for airlines. The 1970s recession and fuel crisis further complicated matters, as airlines shifted to smaller, more fuel-efficient aircraft for point-to-point routes. However, some operators still needed the 747's range and size. Boeing continuously refined the design, increasing seating capacity, range, and incorporating lighter materials and fuel-efficient engines. Eventually, the reign of the 747 came to an end. In response to Boeing's dominance, Airbus began developing the A380, aiming to create an aircraft 15% more economical than the 747-400. Similarly, McDonnell Douglas and Taiwan Aerospace Corporation attempted to challenge the 747 with the MD-12, four-engine double-decker. Despite initial interest, the project failed to attract customers and was abandoned. Considering the threats from Airbus and McDonnell Douglas, Boeing explored the idea of supersizing the 747. They even collaborated with Airbus on studying the possibility of creating a very large commercial transport. Boeing decided to stop the project because it was too expensive, costing around $15 billion. Meanwhile, Airbus faced initial challenges, but they've sold over 330 A380s, and the project is now profitable. The A380 has become an iconic symbol of large-scale aviation. Now there's a new concept on the horizon called the D8. NASA has revisited the double-bubble fuselage design from the late 40s, but with a twist. The D8 features two fuselages placed side by side, a design that promises more lift and greater fuel efficiency. With funding from NASA, a team at MIT and Aurora Flight Sciences is working on a half-scale model, expected to be completed in the next 3 years. The full-sized version, anticipated to be operational by 2027, will accommodate 180 passengers, fly up to 3,500 miles, and reach a top speed of 582 miles per hour. Aircraft makers and airlines have long explored ways to transport more passengers efficiently. Too many engines consuming excessive fuel would drive up operating costs, as seen with the Constitution and XC-99. However, by the time the Boeing 747 emerged, more fuel-efficient and powerful jet engines were available, making jumbo jets more viable. Despite this, changing travel patterns in the 80s questioned the economic sense of hub and spoke models, but the 747 continued to serve a niche market. In the 90s, Airbus intended to compete with the Boeing 747 by making the A380. It was the world's largest passenger plane. While the A380 has gained some of Boeing's market share, it struggled to be profitable because of its large size. Like those big dinosaurs, these huge planes might disappear in this constantly changing aviation industry.